Okay, I got cut off on the last video, and I should have said stop the video and then go ahead and do the on your own problem. So at this point, go ahead and do the on your own problem and pause the video. If you've already done it, then you're one step ahead of me. And then I'll have the answer up there in just a second for you all to look at. Okay, so go ahead and pause the video. Okay, so I'm going to multiply both sides of the equation, or the inequality, by 6. When I multiply both sides by 6, then I distribute the 6 on this side. That's where I got this step right here. And again, this is the step I tell students that I try not to skip. I tell my students not to skip either because a lot of students will make mistakes if they skip this step. So once I write this step out, then the fractions clear out, and I reduce to clear all the fractions. And so I end up with this inequality right here. And I solved it. I got x is greater than or equal to 13. And here's my graph right here. And I didn't add for involved notation, but it would add for you to be 13 to infinity, bracket around the 13. Okay? Let's go on to the next problem, and it's all these linear inequalities. Let's go and do 6a. If I were to solve this, I get 2x plus 8 is greater than 2x plus 3. And I try to get the x on the left-hand side. What happens here is I get this to go away and this to go away. I get 8 is greater than 3. Isn't that always true? And we talked about this when we talked about solving equations. If you get something like this and your variables disappear, that means you'll either get something with no solution or all real solutions. So what this is basically saying is 8 is always greater than 3. That means is that x will have any value of x we find. So x is a set of all real numbers. X can be anything, right? So if x can be anything, what that means is x set of all x such that x is a real number. Would be fine. Or if you want to do an arrow rotation, anything from negative infinity to infinity would be appropriate. And sometimes people just put this little symbol for real number. So these are all the solutions you can represent. And so I tell students at this point, if I were in a classroom setting, I would ask a student to give me a favorite number. Let's say your favorite number is 3. I put 3 in here and here. When I do that, I get 2 times 3 plus 4. Is that greater than 2 times 3 plus 3? That gives me 2 times 7, which is 14. Is 14 greater than 6 plus 3? 9. Okay, so that works. I just chose the random number 3. Someone else might pick the number 8 and put it in there. If you put 8 in there, you'll get another true statement. If you pick 100 and put it in there, that'll be a true statement. So you pick any number for x and it would work. Okay, and again, I'm not in a classroom setting, but I usually ask 3 different people to give me a random number, and it would always work. Okay, let's go ahead and do part B. And I'm going to go ahead and I'm going to solve this. I'm going to subtract x on both sides to get x on the left-hand side. And notice that these drop out again. I get 7 is less than or equal to negative 2. Is 7 less than or equal to negative 2? That's never true. That means we have no solution. This little symbol here represents no solution. You can also write no solution. Either or. That means if I were to look at my original inequality here, and I would pick a number, say I pick the number 5. 5 plus 7 is 12. 5 minus 3 is 3. Is 12 less than or equal to 3? No. So you can try any number. There's no number that you can put in for x that will ever make this inequality true. There's no solution. Okay, so let's go ahead and start doing some word problems with these inequalities. And example 11 is a real-life problem that we could use to solve an inequality. Acme Car Rental charges $4 a day plus 15 cents per mile, whereas Interstate Rental Agency charges $20 a day and 5 cents per mile. Well, this company charges less a day but more per mile. More a day but less per mile. How many miles must be driven to make the daily cost of Acme Rental a better deal than Interstate? Okay, so Acme, we'll go ahead and write here Acme versus Acme versus the other rental place, the interstate rental. Interstate. Okay, so Acme charges $4 a day plus 15 cents per mile. We don't know how many miles we're going to drive, so we'll call that M. And interstate rental charges $20 plus 5 cents per mile. Again, we don't know how many miles. How many miles must be driven to make the cost of Acme rental a better deal? So we want Acme to be less than interstate. That'd be a better deal. So we'll go ahead and solve inequality. I'm going to go ahead and subtract 0.05 m from both sides. So I get 4. I subtract 0.0. Let me put a calculator here. So 0.15 minus 0.05 gives me plus 0.1 m less than 20. I'm going to go ahead and subtract 4 from both sides. So that gives me 0.1 m is less than 16 divided by 0.1 on both sides. So m is going to be less than 16 divided by 0.1, 160. So Acme Rental Company will be a better deal than Interstate if you drive less than 160 miles. Let's think about what this means. So if I drive less than 160 miles, this is going to be cheaper. It could be less than Interstate. What happens when I drive exactly 160 miles? This goes back to what we talked about in chapter 1.2. If I drive exactly 160 miles, they're actually going to be equal to each other. So both Acme and Interstate will be the exact same cost. And if I drive 160 miles, more than 160 miles, that's when Interstate is going to be the better deal. Okay? So again, I'm going to have you guys try one on your own, and this one is a bank, charges $8 per month plus 5 cents per check. A credit union charges $2 a month but 8 cents per check. So again, this one's got an initial bigger charge but less per check, smaller initial charge but more per check. How many checks should be written each month to make the credit union a better deal? So before you guys get started with the problem, I'm going to give you a little hint. That's $8 is 5 cents. So you don't want to call this 8 and it's just 5 because that will represent $5. 5 cents is the same thing as 0.05. That's how many dollars it would be. Okay, so you can leave this as 8, then you would call this 0.05. Okay, so go ahead and get started on that one. I'll go ahead and pause the video, and then you can check your answer against mine. Okay, so I went ahead and did the problem. To represent the cost, the local bank cost is $8 plus 5 cents per check. The credit union was $2 plus 8 cents a check. And I wanted the credit union to be a better deal, so I made the credit union a smaller value. I want the local bank, when did the local bank cost more money? We want the credit union to be less. I pointed the inequality sign towards the credit union because I want that to be the cheaper of the two. So I went ahead and solved it. And when I solved it, and I tried to get checks on the left-hand side, I had to divide by negative values, so I actually reversed my inequality sign. So I got C to be less than 200. So the credit union is a better deal when less than 200 checks are written. So 199 or fewer. Okay. I like the problem because you had to remember to convert the cents into the decimal dollar amount. If you left it as 5, 8 plus 5C, then that would have meant each check was $5. You don't want to represent that either. Okay, so that's the end of the inequalities, solving linear inequalities section. Just gotta remember a couple things in this section. We gotta remember how to graph, do integral notation, set-bill notation for inequalities, and then when we divide or multiply both sides by negative value, we have to reverse the inequality sign. Okay, that's the end of the section. So go ahead and stop the video, and then give an assignment to work on, whether it's in class or whether you're in my online class.